Section 2.3, Visualizing Variation in Categorical Variables. In general, we would like to visualize the distribution of a categorical variable the same way as we do numerical variables, because we want to display the values or the categories of the variable and the number of times that each of those occurs. One way we can do this is with what we call a bar graph. A bar graph shows a bar for each observed category, and the height of the bar is proportional to the frequency of that category. Now, we talked about histograms in the prior section, and histograms and bar graphs can look a lot alike and be sort of deceiving and confusing, but here are some important differences and ways you can tell them apart. One way they're different is the order of the bars. Histograms, the order matters because the numbers have to go in order. So you have to label your histograms in numerical order in order for them to make any sense. However, in a bar graph, order does not matter because categories have no order. So for instance, if you're doing eye colors, it really doesn't matter if you do green, blue, hazel, or if you do hazel, blue, green. Order doesn't matter. It doesn't change the information being displayed. Width of the bars. In histograms, the width also matters because it would change the numbers that are included. If I make my bins wider, then I include more numbers. If I make them narrower, then I don't include as many. So if I change the width of those bins, it changes what I am displaying. However, in bar graphs, width doesn't matter again, because the categories won't change. So I can choose to make very wide bars for blue eyes or a very narrow bar for blue eyes, and it doesn't change the fact that it's still blue eyes. And the third way that they are different is gaps between the bars. Histograms, there are no gaps between the bars because all values are included. And we talked about on a borderline, we go with our right-hand rule, but all numbers have to be included in some way on our histograms. In bar graphs, we do have gaps between the bars because there's no such thing as an observation between two categories. So an example there would be maybe your categories are freshman, sophomore, junior, senior. There's no in the middle of that. You are either a freshman or you are a sophomore. Technically, there is no in the middle value between those categories. A couple more definitions here. We've got a Pareto chart. That's a bar chart that is sorted from the most frequent category to the least. So it's just a sorting. And finally, we have what we call a pie chart. It's either called a circle or a pie graph or chart. It's a circle that's sliced into several pieces. Each piece represents a category of the variable, and the area of that piece is proportional to the relative frequency of that category. Now, some notes on pie charts. These are not commonly used by statisticians or in scientific work. And here are a couple of reasons why. It can be hard to distinguish between slices of similar size. So if you have one slice that's maybe representing 20% and a slice next to it that's representing 25%, a lot of times the human eye has a hard time distinguishing that one of those is larger than the other. So unless it's labeled very well, it could be a little bit confusing to know which of your slices are larger or smaller than others. It can also be hard to read if there are too many categories. In general, they're best used if there are 5 or less categories that you're slicing your circle or pie graph into. There is one major pro to circle graphs or pie charts, and it's that they show parts of a whole really well. So one of the times you would maybe choose a pie chart over a different type of graph is if you want to visualize percentages out of 100. If you really want to show that the whole pie represents the entire 100% and you want to parse that out into different percentages.